Hello, and welcome back to Learning with Lee. In today's episode, we are going to take a look at files, how you can open and use files, as well as some of the utilities that exist to operate on files, and things such as relative paths and absolute paths. I'm going to be going a bit quickly through some of this, in part to avoid another 30-minute marathon of an episode like the last one. So, bear with me in case I go a little bit quick on it. The first thing we're going to take a look at is paths. And the concept of a path is just this. I happen to have a file somewhere on my operating system. I need to be able to figure out where that is, and my operating system needs to be able to track it and know where it is within there. An absolute path just is going, okay, I'm going to start from the root of my file system, up here, from some particular hard drive. And this little C: section is just there to tell you that you happen to be dealing with something that is mounted on your operating system, and that just means that it's a device that can be effectively treated as though it is a folder and can be used in order to create different file structures on there. So what you do then is you go, okay, I'm going to start at C:/, and the backslash just means I want to go within that particular mounted object or within that folder. I'm going to get down to users, add on a little slash after it, head down to Lee, add on a slash after it, and then I can access my document 1. And that's the absolute path. If I hop over into here, and you can take a look at it, how it has this little E:/, saying that I'm currently on my E drive. I'm within the Fraps Movies directory, then within there I'm in the, Learning with Lee directory, and I just added a shortcut to itself within itself, but that's just something we don't need to worry about. And then I'm within the episodes folder within there. So that happens to be an absolute path. And you can use this for pretty much any hard drive, and you can use it from anywhere within there. And these are much more common back in the days of command prompts and the like. Because let's say that I currently was operating within Lee, and I was in a command prompt, and I wanted to go over to D:/photos. Well, the quickest way to do that is say, okay, I need to change directory, and in Unix this just was CD to change directory, and I would input D:/, and there's one important distinction between Unix and Windows. And by Unix I'm including all things Linux, even though I know that that's a bit of a gross oversimplification of their relationship, as well as also Macintosh. And in Unix-based operating systems, you end up using a /, whereas in Windows, you use the \. So that happens to be an important thing to note about the difference between the two, but otherwise, pathing is basically the same between them. So you just go, okay, I put in D:/, and then photos, and I would put a little \/ after it in order to specify that I wanted to be within photos. Technically, I don't have to typically for those ones input that little \/ there, but in case I wanted to access something like me.jpg while I was in here, I could go, okay, D:/, photos \/ me1.jpg, and I could open it up. I could do some different operation on it if I had some utility that ended up operating on JPEGs for whatever reason, whether it be like Photoshop or something else, in order to open it up. And I could do that directly from here. An alternative would be, let's say that I am in Lee, and I want to access a file that's off of some other user, and we'll just call this person B. And that person happens to have some little document on here, D, and I want to access it. Well, I could go, okay, I need C:/, need to head to users, then to B, then down to here. However, there is a bit of a faster way. And the faster way is that there are two different things with paths that you can end up using. The first is a single dot. The second one is 2 dots. And each of these has a different meaning. The single dot says, give me where I currently am. So if I'm in Lee, it gives me this directory, and I can go something like // and then my document 1 in order to specify that that's what I end up wanting to access, or something like that. It's useful for basically in case you need to do what's known as a relative path, and this is also what this is in this case here. And the double dot is also useful for relative paths. The double dot says, rather than being where I currently am, take me up one level to my parent. So a double dot would take me up to users. A second double dot, in case I added \/ and then a second double dot, would take me all the way back up to here to C. However, if for whatever reason I didn't know where I was in regards to this tree hierarchy, then it would take me up to basically my second parent up. And relative paths and using these double dots are much more common in programming than they are in general use. And the main reason is that you don't necessarily know where a user is going to install you on your operating system. So I might end up having my execution within one folder, and I know that within here I have a whole bunch of other folders. So I want to go, okay, give me dot, backslash, give me some folder here, give me another folder, and then give me some item within there. And I know that it's going to be there because that's how I end up in my installation process ends up extracting itself onto their operating system. Alternatively, in case I happen to even want to just be a bit more efficient about it, I can go, okay, for this case here, I'm going up to users, then I'm going down to B, so I just would do this dot dot backslash and then B. I would backslash and get D out of there in order to find its file. And that's really all that you need to know about pathing, relative paths, and absolute paths. One of the important things that we are going to have to deal with is the fact that there are permissions. And that just represents the idea that I have access to some file that I created, I have the ability to edit it and open it, and I might not want other users on the operating system to be able to edit it. I might want them to be able to look at it, such as this image here. I wouldn't want you guys to all of a sudden start going in and editing it, or some of the stuff that I upload to my G drive, I wouldn't want you guys to end up being able to then all of a sudden re-upload something and might end up being a virus that could infect other viewers. So that's something that I want you guys to only be able to read. I don't want you to be able to write to it. And there's a few different categories. There's basically me, and traditionally users have belonged to groups. So then there's the group of users I belong to, and then there happens to be anyone else outside of that group. And each one of those different people has their own particular permissions with regards to some document, and really with regards to pretty much any document. Then, within there are a few different further split-ups of it. You have the ability to either read that document, write that document, or append to that document. Because I might not want you to be able to delete anything that's already been written to a document, but I might want to allow you to be able to write additional data to the end of that document. So I might give you the ability to append on, but not the ability to write to it. Or, as I said, I might give you the ability to read it, but not be able to actually write to it. And that's a fairly common thing that you'll see in businesses and in things such as the military and just for general security. So that brings us back to Fopen. And Fopen takes in two different things. The first is a path. The second is a permission. And if you don't have the permission that you were trying to access, such as in case I try to access demo.txt and I want to write to it, I might not have that permission. And if I don't have that permission, it'll fail to open it and it'll return null. Fopen will also fail if, for example, that file doesn't exist and I'm trying to read it. Or, one of the important things to note about Fopen is that if it doesn't exist and you try either write or possibly append or what's known as append plus or write plus, for any of those, it'll try to create that file for you in case it doesn't exist. And the one thing about write is that if it already exists, it'll clear out that file and basically be like, okay, now we're going to start fresh. And that's the important difference between writing and appending, is that write will end up clearing out the file and append will just let you tack stuff onto the end. There's another version, which is R+, which allows you to read and write. However, the important thing about R+ is that it ends up allowing you to write over existing data and it doesn't destroy anything that was already there. So it can act similar to append, it can act similar to write, but it's a bit safer in case you just need to change some of the data that's already written there. But append is more for adding new information. Then there's another important distinction, and that's that certain things are text files, such as this file here. It's designed so that I can read all of this stuff that's in there. It's a sequence of characters that I can read. In case I ended up opening this up with something like Notepad, it would work just fine there. However, if I tried to open up this file in Notepad, it would give me a whole bunch of garbage, as well as also then it wouldn't be able to display it, and it would be a really poor idea for me to try editing anything that way. And that's because this is a binary file. It is designed to be more compact than a text file. A text file, because of the fact that you end up needing at least 1 byte to represent each character in it, is much less efficient for storing something than if, for example, in this case here, I have a whole bunch of ints representing pixels. If I just store those directly as either shorts or as ints, it's going to be a more efficient and easy to use file format. So, in case you want to access or read or write a binary file, you would end up appending on this B, and it should be the final character in this series of what you're trying to do in terms of how you're going to use it. Then, the important thing about file is that it's its own custom struct, and it has some different things in it. The things I've commented out are character pointers that if I try to actually print them out, they'll cause the program to crash. But it's useful to note that they are in there, and occasionally they will be assigned to things that you can read. However, in here, the most important thing right now is this underscore file. And what that is it's just an integer, but it's known as a file descriptor. And the file descriptor is basically how we know where to read and write. It tells the system which buffer to use for input and output. Because usually 0, 1, and 2 are used in case we head on up to like C out here. You can see how it has this like CR data here, or if I head on down to standard out here, see how it has this IOB, which stands for IO buffer function, and then 1. And that's just getting the first, well, it's the second one because it's 0 based, so it has 0, 1, and 2, and typically those go to standard error, standard out, and standard in. And what you're then going to be looking at is that those end up effectively being treated the exact same as a file, even though you're writing to your screen in one case and to a file in another case. But to your operating system, they're effectively pretty much the same as the way that it treats them, because in the end, it just treats them as buffers. So that file tells you which one of those you're actually going into. But the important thing now is that we can read and write to that file. So if I wanted to, I could read in a line from that file. And for this, I'm just going to use fgetS. It's a weaker version of fscanf, which is somewhat of what we looked at with format strings. The major thing is that fgetS and fputS just deal with normal strings. They don't do any formatting for you. So it ends up being less powerful, but as with most things in programming, less powerful means it's less complicated and it'll take less time to actually run on your system, so it's more efficient. One of the good adages is to use the minimum amount necessary to do whatever you're trying to do, because anything that you do that's extra tends to be additional overhead, and in case you don't need it, then you really don't want that extra overhead. That said, one of the famous quotes in programming is that premature optimization is the root of all evil. And while you want to optimize things, if you don't need to optimize things, don't end up spending days and days trying to optimize things. But we'll be getting into optimization in the future. For now, we have fgetS and fputS, and those just can either put something to a file buffer, so in this case here, standard out, but they can also read something from a file buffer, in this case, file 1, because, surprise, surprise, this file buffer ends up being treated pretty much the exact same as standard out. One of the nice things to note about is this FEOF, or file end of file function, because EOF stands for the end of file, and basically what it does, it checks to see if the end of file flag, which is in this portion here, whether or not that's set. And if it is, it'll end up returning a non-zero value, otherwise it returns 0. So that happens to be useful in order to terminate in case you don't know how large your file is, and you're just going, okay, give me a line, give me another line, keep going through a file until I hit the end of it. This will tell you when you hit the end of the file. So that's really useful. The other thing is that fgetS ends up returning a null pointer in case it ends up not being able to get any, and otherwise it'll return basically a pointer to your buffer. Because for certain times you'll end up wanting to keep scooching forward in buffer, such as in case I read a certain amount and I wanted to move forward in my buffer, in case this thing were 10,000 and I only want to do this 100 at a time reading into the buffer, and I might end up doing something like, okay, I do this, and if it succeeds, I then add 100 onto line to move myself 100 further along through my buffer. For now, though, I'm just reading directly into the first location and overriding anything else that was there previously. And the thing about fgetS is that it does end up reading in the new line character, and basically what it does is it goes until it either hits a new line character or until it hits 99 characters, or in this case here, The reason I said 99 is that it's this number minus 1. And that's because it will insert for you automatically a null terminating character to your string. So you don't have to worry about null terminating it yourself. It will take care of it for you. It's also nice because it does have this limit here. It can allow us to prevent doing things like overwriting memory that we shouldn't have access to if for whatever reason our buffer wasn't large enough to handle taking all of this. And then fputS just outputs that to whatever file buffer we supply. So it could be standard out, it could be standard error, it can just be a normal string like this, it can be one that's already defined as a variable. And then there's also fflush. And I already mentioned flush, and that's the C++ way of doing it. Fflush is the C way of doing it. It just takes in basically a file pointer and then says, okay, now we can end up pushing everything out to standard out. Down here, what ends up happening is that you can see this whole little section here. It corresponds to this demo.txt, in which it's going, okay, read in a line, read in this line, read in this line. And this one here is so long, because in case we head over to here, it's actually 149 characters, which you can see down at the bottom here. It's going to end up having to use the buffer twice for that one line, but it does not split it up. It does not insert any new line characters in there. However, it does retain the original new line characters, so I don't need to add in any new line characters myself. And one of the things that we'll get into is that it does make a lot of sense in the future to do things on a line-by-line basis. Occasionally you don't want to, but typically you're going to want to do that when you're processing files. Then what we have is, as you can see here, we're opening up another file, and you can see how we end up going into text files and then to demo2.txt. And in this one here, I've already run it a few times, so you can see in here it has all of these appended on. However, if I had this as a W as opposed to an A, we would only have within here this first line. We wouldn't have the other two lines that there already were. And once again, does null. And then you can end up doing this in terms of writing to it. But there's one important thing about these files that I did not mention yet. And that's that whenever you open a file, whenever you get a resource from the system that's similar to free or anything else that we deal with that's a resource from the system, you must be certain to release it or deallocate it once you're done with it. Because otherwise, you're going to end up having a potentially serious problem that could eventually either crash your system, cause performance problems, and just negatively impact your user. So whenever you end up successfully opening a file like this, be certain to close that file down. And for that, use fclose in C. There's different ones for C++, for C# and Java, but we'll get into those in the future. For now, I think that's enough. And the one thing I would like to point out with fclose is that whenever you end up doing an fopen, you should immediately, after you've input this line here, follow it up by creating the line where you're going to do fclose on it. Because you want to be certain that you do release that resource. I cannot overstate how important it is that when you get a file as a resource, or something else as a resource, that you release it back to the operating system. Thank you very much for watching. Have a wonderful day.